Imagine a world where high noon looks like dim twilight on Earth. A place where the sun's rays are 900 times weaker than what you're feeling right now. This is the absolute edge of our sun's reach, where the solar wind begins to tire. A world so far away that it takes 165 Earth years just to complete a single orbit. In fact, since Neptune was discovered in 1846, it has only finished one single lap around its star. Out here, 2.8 billion miles away, the rules of our solar system seem to break. We're talking about winds that move faster than the speed of sound, a magnetic field that is completely off-center, and clouds that hide a treasure trove of literal diamonds. This isn't a science fiction fever dream. This is Neptune. For decades, we viewed it as a quiet, frozen marble at the edge of the dark. But the truth is much more violent. Welcome to the blue nightmare. Most planets were found by people looking through telescopes, but Neptune was different. It was found by logic. In the early 1800s, astronomers noticed something wrong with Uranus. It was lagging behind its predicted position, then speeding up. It wasn't following the laws of physics as we knew them. It was as if an invisible ghost was tugging on it. This sparked one of the greatest rivalries in science history. Two mathematicians, John Couch Adams in England and Urbain Le Verrier in France, independently sat down with nothing but paper and ink to solve the mystery. They used Newton's laws to calculate exactly where a hidden eighth planet would have to be to cause that gravitational tug. But here's the kicker. The discovery led to a bitter international scandal. The British Royal Observatory was slow to act on Adams's work, while Le Verrier sent his findings to the Berlin Observatory. When astronomer Johann Galle finally pointed his telescope at the exact coordinates Le Verrier provided, Neptune was found within just 1 degree of the prediction. The British tried to claim priority after the fact, leading to decades of diplomatic tension. As astronomer François Arago famously put it, Le Verrier had discovered a planet with the point of his pen. At first glance, Neptune looks like Uranus's twin, but the color is strikingly different. Both planets have atmospheres dominated by hydrogen and helium, with a small percentage of methane. It's that methane that absorbs red light and reflects blue back to our eyes. But why is Neptune so much more vivid? Uranus looks like a faded, hazy ghost, while Neptune is an electric cobalt blue. A landmark 2022 study finally gave us the answer: the aerosol 2 layer. Both planets have a middle layer of concentrated haze formed by photolysis, sunlight breaking down methane into organic particles. On Uranus, this haze layer is twice as thick, acting like a stagnant fog that whitens the planet's appearance. On Neptune, the atmosphere is far more turbulent. It churns up methane snow that acts as a scrubber, pulling those haze particles deeper into the interior and clearing the air. This suggests Neptune's vivid blue isn't just an aesthetic choice. It's a byproduct of a much more violent, energetic weather system churning beneath the clouds that prevents the atmosphere from getting dusty. You'd expect the farthest planet from the sun to be frozen and still, lacking the energy for weather. Instead, Neptune has the most violent winds in the solar system. We've recorded gusts reaching 1,200 miles per hour. That's 1.5 times the speed of sound. Here is the paradox. Neptune receives 20 times less solar energy than Jupiter, yet its winds are 3 times faster. How? Fluid dynamics. Because Neptune is so cold, the atmosphere has very little viscosity or internal friction. Think of it like this. On Earth, heat creates turbulence that slows winds down through friction. On Neptune, the flow is near laminar. Once those winds start moving, there is nothing to stop them. They accelerate into a supersonic nightmare. In 1989, Voyager 2 spotted the Great Dark Spot, a storm the size of Earth. But when Hubble looked again a few years later, it had completely vanished. On Neptune, massive hurricanes appear, migrate across the planet, and evaporate into the abyss, only to be replaced by new, even more powerful storms born from the planet's mysterious internal heat. Here is the real mystery. Neptune is 1 billion miles further from the Sun than Uranus, yet they are almost the same temperature. How is that possible? It's because Neptune has a massive, unexplained internal heat source. It radiates 2.6 times more energy than it receives from the Sun. Uranus, by comparison, is dead inside. It radiates almost no internal heat. This internal engine is what drives those supersonic winds and clears the methane haze. Astronomers are still debating the source. Is it primordial heat, trapped since the planet's birth 4.5 billion years ago? Or is it something more dynamic? Some theories suggest that Neptune's core is undergoing a gravitational contraction, or perhaps the diamond rain we often talk about generates immense friction as it falls, heating the planet from the inside out. Whatever it is, it makes Neptune a heat engine of incredible efficiency, capable of generating Earth-sized hurricanes despite receiving less than 1% of the sunlight we get here on Earth. Deep inside Neptune, the pressure is millions of times higher than on Earth. Scientists have long hypothesized that 5,000 miles down, this pressure tears methane molecules apart, freeing the carbon. That carbon then crystallizes into solid diamonds. In a groundbreaking January 2024 experiment at the European XFEL, researchers used X-ray lasers to prove that diamonds form at much lower pressures and temperatures than previously assumed. This means diamond rain is likely happening much higher in Neptune's atmosphere than we thought. But it gets weirder. Below the diamond rain lies a layer of supersonic water. This is a state of matter that is both a solid and a liquid at the same time. The oxygen atoms lock into a solid crystal lattice, while the hydrogen atoms flow through them like a liquid. This black hot ice is highly conductive and might be the reason for Neptune's bizarre off-center magnetic field. On Neptune, the sky rains gems into an ocean of electrified ice. Finally, we have to look at Triton, Neptune's largest moon. Triton is a rebel. It's the only major moon in the solar system that orbits in the opposite direction of its planet's rotation. This is the smoking gun that Triton wasn't born here. It was likely a dwarf planet from the Kuiper Belt, much like Pluto that wandered too close and was snared by Neptune's gravity. Neptune remains the last great frontier of our solar system. Every new look reveals a world that defies our understanding of physics. It is a place of diamond rain, supersonic storms, and stolen moons. But until we send a dedicated orbiter back to the blue giant, something NASA is considering for the late 2030s, we are just looking through a keyhole at a world of infinite mystery.